Good evening and welcome to this very special episode of the Breakfast Show After Dark, in which we will be discussing non-road mobile machinery, the call for evidence that's taking place literally as we speak. And I say a very quick good evening to Dan Cullen, to Gary Muirhead, to Jim Turner, and to Mark Whiting, who are all in the chat already. If you're watching this morning, you'll know that I've actually swapped shirts, and I've done so by way of an apology. I was at the JCB World Headquarters a few weeks ago, and I arrived. I apologise for this. I arrived wearing a Bobcat branded jacket. Simple mistake, but it was also unforgivable. So I'm wearing a JCB one, which there you are. You should be able to see that there. JC Bamford. I'm wearing that specially to say sorry today. Now, while I was at the JCB HQ, tonight's guest, Tim Burnhope, described the non-road mobile machinery consultation as the most important legislation the industry will ever face. That's good enough for me. That single sentence was the inspiration behind tonight's show. So while I'm coaxing Tim from our green room, please remember, this is your chance to take part, to ask questions and to learn more about some forthcoming legislation that will literally shape the way in which demolition and construction equipment is fueled in the future. So I am delighted to welcome JCB's Tim Burnhope onto the stage. Good evening, Tim.
Good evening. How are you?
Yeah, very well. I've already asked that this is not Tim's back bedroom. This is actually his office. So he's not gone home and sat in his bedroom, which is good to hear. Tim, obviously the first question, because I'm kind of aware of the fact that this is to a degree flying under the radar with some people. What exactly is the non-road mobile machinery call for evidence that we're going through at the moment?
So the definition first, non-road mobile machinery, or NRMM as it's called, that's what it stands for. And interestingly, it covers a huge number of sectors. So it covers construction, agriculture, waste, demolition, ports, forestry, industrial, mining, quarrying. It's very, very diverse, and it includes all of the machinery used in all of those areas. So for us, it's everything from a mini excavator to a very large excavator, backhoes, load hauls. But of course, it also includes, for some of those sectors, everything from a chainsaw right through all the agricultural equipment to tractors, right up to combines and very, very large agricultural equipment. So it really is a very, very complicated call for evidence, probably the greatest number of product groups of probably any industry.
Who's actually called for the consultation? I realise I think we're moving towards sort of a global standard, but this is very much a British thing at the moment. And I know from our experience up at your headquarters a couple of days ago, the French are working on something very similar. I'm sure this is being rolled out across across the world rather. But who's actually called for this here in the UK?
Yeah, so this is actually from 3 government departments. So it's from what we call DESNZ, which is the Department for Energy Security and Net Zero, which I guess was the old base for business and energy and those sort of sectors. But it also comes from Department for Transport and also from Department for Environment, Farming, Rural Affairs, as we know as DEFRA. The net zero strategy for the equipment is actually controlled by DESNZ. Interestingly, the roadworthiness and the road rules for equipment going on the road would be covered by DFT. And then interestingly, the element of air quality would be covered by DEFRA.
Okay, I've just had a notification that we've got a problem with LinkedIn for some reason. Don't know why that is. Let me remove that and I'll put them back on in just a second. Yep, that seems to have done it, I think. You mentioned the breadth of this consultation and ultimately the legislation. I'm kind of caught in 2 minds with this. There's a part of me that thinks the fact that government and government departments have gone out to the market and said, look, we're not the experts, you are, please tell us how we should proceed. But then there's another bit of me thinking, by lumping everything from chainsaws to port handling equipment and all points in between, that's making it one hell of a complex thing, isn't it?
Yeah, it's very, very difficult. So we've kind of worked with government to explain this. It's very difficult to do because naturally you either pick a product group or you pick a segment. The big challenge we have in our industry, so if you take any particular product, well, give an example, a telescopic handler. It can be used in agriculture, it can be used in forestry, it can be used in construction, it can be used in manufacturing areas. So the problem is we've got product groups that cover literally all of the segments. There are others that are very, very specific, but the majority really do cover all elements. I mean, if you think just about our submission, we today at JCB have 16 different product groups. So whether it be a backhoe, a load haul, a wheel loader, a mini excavator, but we cover over 350 different individual products. And trying to break it down and work out what's the right technology for the right product, it's really, really difficult to write down and explain. And you can imagine if you're the government and you're getting hundreds of responses back, to then take that and understand it is a real challenge.
Yeah, one of the things I've read through the NRMM documentation as it stands at the moment, and one of the things they're looking at very closely is kind of a predicted use case. So, how many hours a day a particular item of equipment will run. Well, a chainsaw is going to run a very different set of durations to a backhoe loader or a port handling crane. That's going to be so complex, isn't it?
Yeah, but I mean, again, if you take the example of the chainsaw, many people will use even a small electric one today that maybe only lasts 19 minutes on a battery, and then you use multiple batteries to go and recharge, and it's great for cutting small branches off as you start to bring the tree down. But of course, when you get to the main element of the tree, you want a full-blown, maybe a 20 or a 28-inch bladed chainsaw that you want to run all day long, consuming quite a few litres of fuel to do it. So it's no different whether it's a small excavator or a big excavator. You've got the challenges of some do a couple of hours of full power a day. Others may want to do 22 hours of full power a day. So it's a real challenge to be able to communicate that back and try and explain that to us. I mean, we understand our product groups. We don't necessarily understand, for example, chainsaws and their application too well. So it really does call upon every industry that are experts with their own product groups to put that information back across to government.
The thing that prompted this get-together tonight was you actually said, and I wrote it down at the time because it really did trigger with me, you personally described this as the most important legislation this industry will ever face. Why do you believe that?
Well, I'm really passionate. I'm passionate about a few things, but the most important ones are that we've got to get a net zero solution for our industry. It's much better that we work out what technologies work for our products. So there may be different technologies and different fuels that we can maybe use, but it's important we as an industry work out what we need and what will work best for our customers and what will be adopted to allow us to get to net zero in 2050. The danger is if we don't experiment and come up with the answers, then the government have no choice but to choose one technology, and therefore it could be unsuitable for our industry.
We've had a couple of questions in from the audience, which under normal circumstances, I wouldn't say I'd ignore them, but I don't think that I wouldn't have thought they'd be appropriate, but they are for a different reason. Mick Norton has said, question for JCB, are JCB engines built in India and China meeting the same stringent UK specification regarding emissions? And Ken Hatcher has said, are the Chinese working with this directive with JCB? The reason I've put that up on the screen is we're talking about NRMM, which is a British thing. But we've also got a huge representation of overseas brands, be they Chinese, American, Japanese, Korean. All of those manufacturers are going to have to comply with NRMM at some point. Are they part of the consultation that's going on at the moment?
Yes, I mean, the definite manufacturers that would be selling in the UK today would be aware of this. And of course, most of them are members of our trade bodies. So our trade bodies are working with all manufacturers to make sure that it's communicated as a document, and the trade bodies will act on their behalf, on the industry's behalf, but will also encourage people to put their own evidence forward to suit their solutions. So we do make engines in India. We make a substantial number. I think we make between 400 or 500 engines a day here, and exactly the same in India in a factory that is identical, same quality, same emission potential levels, whatever it is. Same quality levels, outstanding technology. So the one thing that I think we must reflect upon is, if you think that the British government were the first to come out with the strapline that all cars will be, petrol or diesel will be banned for all cars by 2035. And they maybe didn't have all the answers at that time, but they decided on the technology, whether it be a battery or a fuel cell, and that was written out as kind of a rule to work to. And then today, now the car industry has a zero emissions mandate where we must achieve X% of electric cars per year all the way through to 2025. And it's really starting to come into action to be enforced. Now, you could argue at the time that as that was developed, the car industry hadn't had the opportunity to show all the alternatives at that time. And as a consequence, ended up working to that rule. The other danger is then places like the European Commission may take that ruling from Britain and just roll over the statement and say we want to do the same in Europe, and they would vote in the same. So a lot of headlines out there, and what we want is to have clarity to make sure that headline in future for non-road mobile machinery is absolutely what works for our industry.
One of the things that struck me with, obviously, you speaking about it personally, is the fact that JCB has got a foot in both future fuel camps. You've obviously got your electric and you've got your hydrogen. How are you personally expecting this to pan out? We had a guest on the show this morning, and he was talking about electrification and trying to suggest that hydrogen was not necessarily the panacea. Are you seeing a future with a mixed fuel fleet?
Yeah, I think one of the dangers that possibly we are starting to see in the car world is that one technology is pretty being chosen and focused upon, and that's always dangerous. You know, for example, for the last 20 years, we were told what tailpipe emissions we should achieve. So from sort of tier 0 all the way through to stage 5, we had to reduce tailpipe emissions by 98%. Nobody told us what technology to use. We just worked out how to get there. And I think the one thing we want for our industry is we want to be able to use all the alternatives that suits that incredibly wide and broad range of equipment. So there is definitely a place for battery. There's definitely a place for hydrogen. We think there's definitely a place for hydrogen combustion. It gives us all the benefits that it does. There'll maybe be, some people may use HVO if they're comfortable with it in the short term. Some of the ag people are looking at maybe methane gas. Does that work? Does it not? The good thing is we've still got, a good 25 years to work at to get to 2050. So we can develop all of these technologies and we'll work out which technology is absolutely right for which application. The thing that's different with our industry is we sometimes forget that we are unique, especially in construction, where we work on many, many job sites where we do not have access to the fuel electricity. We're sometimes naive that we think we could tether all of our machines, or the majority of electricity on our sites today is provided by diesel generators. And I think we sometimes undercall that. I'm not even sure if diesel generators, the electricity produced by them is even included in the grid calculations of the future. And we've got to remember a big excavator that would run on many batteries. We could say if you wanted to work 16 hours with a 20-ton excavator without stopping, you'd probably need something like 8 to 10 tons of batteries on board. 400,000 pounds of batteries on a machine today that might cost, 140, 150,000 pounds. An incredible number. You'd need a fast charger that would have almost a megawatt of electricity, that would wipe out many, many homes. If you've got 100 of those machines on site, you'll start to wipe out local towns with the electricity that you need. So a lot of people talk about the technologies, but they don't get into the detail and understand the mathematics of what's involved to make those technologies work.
I know when I was up at your facility, not last time, at the time before, when we were looking at the hydrogen machines, one of your team there said, you'd been down the road and you had figured out that it is possible to electrify anything. The question is not whether it's possible, it's whether you should, which I think kind of plays into that, doesn't it?
Yeah, we looked at our quarry. So we run a fleet of test and development machines. We've got at any one time, we've got 200, 250 machines in our own fleet. And of course, many of those are on endurance, working 24 hours a day. And naively, when we thought, well, maybe they'll all be batteries in future, then we thought, well, how are we going to charge them? And all of a sudden you think, well, maybe I need 100 charging points, or do I need 200 charging points? you work out how many megawatts you need to do, and then you realise that you can't join a local substation 7 miles away, Cheadle. You'd have to dig to Birmingham, 43 miles away, at £1 million a mile to get cable sizes in that are, the size of dustbins when combined. And I think we don't realise we're quite lucky where on our job site we don't ever move, but of course our customers may be moving every 18 months or shorter or longer. And we've got to acknowledge that we don't have necessarily access to electricity in the quantity that we need. We have customers that have looked at that, talked to the national grid, and they maybe have predictions of 5 to 10 years before they could get that size of power in their area to do that job.
But hydrogen is not currently the answer, as far as I can tell. And one of the things that leapt off the page when I was reading the NRMM consultation document is the fact that they are currently estimating costs of £7 per kilogram, initially falling to £2 per kilogram by 2050. So with the cost of hydrogen, and that is only an estimate, with the cost of hydrogen currently a bit of an unknown, isn't that going to put off a lot of people actually converting to hydrogen en masse? I mean, even setting aside the fact that we don't currently have the infrastructure in place.
Yeah, I think there's kind of a lot said. I think it's difficult where we haven't, we're still really trying to embrace electric for electric cars at the moment as a country. We've not yet thought beyond that. There are one or two entrepreneurs that are doing a good job to really push that. But what we're starting to see now in other parts of the world is real excitement. So we've seen recently, for example, in Europe, the EU have now got a plan to make produce themselves over 10 million tonnes of renewable hydrogen within its borders. And then they're also planning to have an additional 10 million tonnes imported from other regions. You'll see they've been signing deals with areas like Northern Africa, where they've got lots of sunshine and lots of wind, especially along some of those coastlines. So they're starting to earmark and target two euros per kilogram by 2030, which I think is ambitious. I think if it was twice or even 3 times that, we'd be happy. We've seen in the USA, they've unveiled their US National Clean Hydrogen Strategy, a real clear roadmap now, which is aiming to accelerate the production. Not just the production, but the delivery and storage of how they use hydrogen. They're at the forefront, some even now using liquid hydrogen. And this is supported by what you may have heard, the Inflation Reduction Act that everybody is talking about in America, which subsidises green hydrogen up to about $3 a kilogram. That will allow them, their plan is to try and get to $1 per kilogram of hydrogen by 2031. Again, very, very ambitious. But those businesses are now being funded by US government to get going on the journey of starting to produce hydrogen. India, where we're well represented in that market, it's really exciting where India sees itself as a great market for green hydrogen. I think today India would import the majority of its fuel from other countries such as Russia and Iran. India would love one day to be self-sufficient for fuel, and green hydrogen would be the perfect solution. India's got many, many days of many hours of sunlight, fantastic wind opportunities as well. So again, they're starting to think about how do they produce green hydrogen for $1 a kilogram again by 2030. And what we really need is we need to put in our information, the call for evidence. And as the governments of the world start to develop plans for NRMM, we just want to make sure hydrogen is one part of that, to allow for the delivery of a mobile fuel. Of course, when those plans come out and people realise that they need to supply, there will be a market in construction equipment, for example. They'll get behind producing hydrogen much quicker because they know where they'll supply it, and the two will start to come together. So it's chicken and egg, and what we need is both defined and a plan for both, so we get on and make this happen.
One of the things, and I've just said it out loud, and it was only when I said it out loud that I realised I lack the understanding on this. £7 per kilogram of hydrogen, or £2 per kilogram of hydrogen. What do you actually get back from a kilogram of hydrogen? But is there a set of maths that you can do that equates it to diesel, for example?
Yeah, so we always use the pretty simple ratio of of 1 kilogram of hydrogen is 3 litres of diesel. So, you know, if diesel is around 150, then we're looking at £4.50 a kilogram for hydrogen. So as long as we're in that ballpark of 450, 5, 6, 7, I mean, we have had some customers we're talking to that would gladly start to demonstrate machines in the early years for just under 10 to get going and start to produce the sites and understand it. But realistically, I mean, if we got down to that number of around 4 to 5, we'd be in a great position, because we would be equivalent to the diesel price that's paying today. The numbers that they're talking around of $1, you know, or the US of $1, then that's fantastic pricing. The other regions that I've not talked about that are really starting to make progress now are the Middle East as well. So again, areas that have got wind and lots of days of sunlight, solar, to produce green hydrogen is fantastic, to produce low-cost electricity, therefore to produce low-cost hydrogen.
I'm going to throw over to the chat. Jim Turner has said, my thought was that HVO would have been a great replacement for red diesel, meaning we would be paying loads of tax and the emissions would be a lot better. But I've heard HVO hasn't got the same qualities as diesel as regards its shelf life. I mean, JCB can run on HVO. What is the JCB experience on HVO?
Yeah, so we approved our engines for use on HVO, I think late 2014, early 15. Some customers are using HVO. We must remember that HVO has carbon reduction benefits in its manufacturing process, not at the tailpipe. So good quality HVO, I think, would be comparable to diesel. But again, it's a carbon credit based on where it's manufactured. The big concern at the moment is organisations are struggling in some cases to prove where it was manufactured so that it brings about the right credentials. If it's made with certain palm oil, then people think it's inappropriate to use palm oil. We should be using that for food production. So therefore, really, they're looking at recycled oil. We've got to make sure we have a supply chain that is very credible and very sound to ensure that most of it comes shipped in from Asia, I think, at the moment. So it's making sure that we audit all of those manufacturing processes to make sure they have the true reduced carbon credentials.
Another question, this one from Mick Norton, who says, question for JCB, are there exemptions proposed within this legislation? I mean, on the basis we haven't got the legislation, maybe too early to say that, but I wonder if you have an answer to that?
Yeah, I think it's too early to say. I think the evidence itself hopefully will point to those key products, which will be very, very difficult to change. I think government do agree that we are in the hard to decarbonise, hard to reduce or hard to decarbonisation reduction. We're in the most difficult group to try and eliminate. So they're very, very aware of that and what's needed. So the process going forward from here is we put in the call for evidence. The government will then take its time to review every question. I think there's the core questions, about 67 of them, that they will review based on all of the submissions, and then they will start to develop their net zero plan for NRMM from that. They'll pull that together, and then we'll go through a period of consultation where such potential exemptions may exist, or timing, or challenges on timing, or recommendations. So we've got some way to go. What I think is really healthy and why it's so important to me is that we must share as much evidence as we can as early as we can. Really, really important that we all share our learning at what works and what doesn't. And then if you've got real good hard evidence, good data of what works and what doesn't, whether it be good or bad, we should absolutely share it so that we've got as much information passed to government to allow them to make the correct decisions.
It's interesting you mentioned data. I've got a few more questions over in the chat, but I just noted down myself. Thanks to your LiveLink system, data, you must have data coming out of your ears. You know, real specific use cases of, you know, working hours and that kind of thing. You inundated with data.
Yeah, I mean, we were delighted to introduce JCB LiveLink, and it is live data. That's why we call it LiveLink. Way back in 2010. I mean, it's incredible today. I think we've got somewhere between 450,000 to 500,000 machines with data streams. And it's just fascinating where we can work with our customers and understand exactly what products do. And, we hear lots of things and people tell us certain things on number of hours or distance moved. I'll give you a great example. So we were looking at mini excavators the other day. So in that document, it maybe suggests that it would be possible to tether all small excavators because they don't move very far. Interestingly, our GPS system from telematics would tell us that our mini excavators can quite easily, even on their own tracks, move at least 1 kilometre every day. But the other remarkable thing we picked up that we hadn't even thought about was some of those that work for the utility companies move over 36 kilometres a day on the back of trailers. So they go from site to site, fixing water pipes at the side of the road or a gas pipe or doing... And what we realised, those machines are incredibly nomadic. They're just constantly moving. So when you start to think, could you really tether that machine? It means you've basically got to have, the only way you could tether a mini excavator is to take a diesel generator with it all day long. And again, we can share that evidence to say that is just not practical.
That was one of the points of that documentation when I actually scratched my head, because there is quite a lot of mention of tethering. And I can think of probably 2 or 3 applications where tethering makes sense, and about 500 where it doesn't make sense. We've got a question here, and this seems to be like a moving goalpost question to my mind. What size of excavators does hydrogen fuel not make it feasible? Is it going to be 14 tons and above for hydrogen and electric below? Every time I think that's likely to be the case, somebody comes along, like a Volvo come along with an electric 20-tonner and kind of blow that out of the water. Are you seeing any kind of clarification on that yet?
No, I think the challenge is we as engineers can do anything. So what we've got to be very careful of is that we don't bring to market products that suggest they can do, say, a full day shift, but they can't. And we could do an excavator that runs for 2 hours and put batteries on, and then it goes off and charges for a couple of hours, but we sometimes forget how a construction site works. So, if you're running an excavator and you've got a cycle of 6 or 7 articulated trucks that you're feeding every minute, if you park that excavator up, you park up all those articulated trucks. So it's the same with all the load hauls that we have in the UK, the telescopic handlers. They are feeding bricklayers all day long. And people forget, that those units are there to work. And when they don't work and they don't feed, then the rest of the site comes to a grinding halt. So the expectation with some of these primary products, excavators should be running all day to make sure those dump trucks are running all day. It's really, really crucial. Telescopic handlers have got to run all day. They've got to be there for every minute that those bricklayers there, and we've got to keep feeding those bricklayers. So we've just got to understand what our products do every day in the application. And we mustn't forget that they're a work tool, and that's what they do. They work to provide material in most cases to get the job done. And I think that's the crucial element for me. It's so easy as an engineer, and I'm guilty as everybody else is. We start by looking at the technology. So yeah, we could tether everything if we wanted to. It'd be really easy. But of course, even those big excavators are out there today on tethering. They do have to be sent around with a diesel generator to get them on and off trucks. It's common knowledge. If you want to move them, those cables are huge. This document says you need a 20-meter cable, and that's all you'll use. These machines move more than 20 meters. You dig with a big excavator more than 20 meters. And again, where do you plug that machine into? Where is the grid connection that allows you to have that connection within 20 meters of that machine? So we've all been on big sites. We all know how they work. And but you can justify in your own mind that would work from a technology because it's fairly efficient. Exactly the same with batteries. We realise that batteries are probably great for small machines, maybe under 3 or 4 tons. You've got the minimum number of batteries on, so the cost isn't too much more. The machine would only be twice the cost, not 3 or 4 times the cost if you put them on a big excavator. And you've got to have access to the fuel, which is electricity. The fuel is not the battery. The battery is just the fuel tank. We sometimes forget that. You need access to electricity at all times to make those machines, to be able to recharge them and make them function. So I think it's really important. We looked at things like battery switching on big excavators, but you've just got to do simple calculations to realise that if you say you want to run a big shift and you've got 10 tons of batteries on, so okay, if you had 10 tons of batteries on an excavator to do a full 16 hours of shift, well, okay, let's reduce the size of the battery, so only put 5 tons on. So you put 5 tons on and you run for 8 hours. But when you do the calculations, if you have to take that battery off, yep, you can take it off in 10 minutes, but you forget you've got to probably travel 35 or 40 minutes to get to a charging point, the size you need. So every time you do those calculations, and we've done it many times, you would need 3 5-ton batteries. You'd need 1 in transit, 1 on the machine, and 1 being charged. So every time you do that, and you say, yeah, it's possible, but what it says is you need 1.5 times the batteries you would if you just had it on the machine, and you need a truck to deliver it, and you need a driver with the truck. So you've got twice the equipment and 1.5 times the batteries to make it work. So we try and get back to the mathematical calculation in all we do to get to those real solutions.
That's the maths, but there's also, and it was you that reminded me of this, you personally, when we were looking at the hydrogen machines. Somebody has said in the chat that JCB machines are not cars. They are not cars, quite obviously. Cars go to the fuel. In construction, the fuel comes to the machine. That's as big a paradigm shift, I think, as actually switching fuels. The very fact that we possibly have to start learning to take machine to fuel. That's a big change, isn't it?
Yeah, I mean it's pretty impossible. I mean, if you think of some of the biggest job sites, you may have 100 big excavators working on big job sites. They probably track out from the compound. If they do, well, they maybe get left in situ. But the fuel that's consumed in just tracking them, maybe a kilometre or whatever to the front line, you can't possibly come back every half day or go through that process of consuming the extra fuel. And most of it is the time that's lost. We've built an industry on fantastic delivery of diesel via simple bowsers, and we keep the machines working. The beauty about hydrogen, our customers asked us to look for a zero carbon fuel where they can recharge the machine or refill the machine in the same 7 to 10 minutes as you can with any normal machine. And that's the bit that's exciting. You can keep that machine working. That's the crucial part.
Mick Norton again, question for JCB. You don't have to preempt everything with a question for JCB. I'm just going to assume it's not for me. Recently, a Chinese container ship brought 7,000 Chinese manufactured EVs into a European port. Is it possible that the Chinese might start dumping similar quantities of construction equipment? And if so, how would NRMM apply? Obviously, we're aware of the anti-dumping investigations that are going on excavators and that kind of thing. But how would NRMM apply to imported machines? Is there a special dispensation in there or something like that?
No. Any rules or any regulation for the UK market, any product that comes in from anywhere or is made within the UK would have to comply with the regulations within this country. So that's always been the case, and that's what we'd work to. We do have to be aware that I think anybody that knows the Chinese market statistics today, the internal market has reduced significantly, causing basically a flood of exports into other markets around the world. So we are expecting a challenge where more and more machines they'll try to import more machines. I'm sure they'll do it at very competitive prices, as long as that's done in line with the law, then that's fine. Obviously, for many years there's been issues of dumping with potential machines from other parts of the world, so we don't want to see the same. It must always be a competitive and fair playing field that we all work in. We mustn't walk away from. China is the world leader in battery cell manufacture. I think 77% of all battery cells are manufactured in China. They have, we talk about building gigafactories here. They've got not just gigafactories, but some of their gigafactories in theory are 10 gigawatts of of power, they have a substantial investment and are way ahead in that technology. So they will naturally move towards electric products as a consequence of having that technology available. However, the most interesting thing, when JCB a few years ago, when Lord Bamford announced that we were doing hydrogen combustion to the world and the reasons why it's a great solution, we were probably the first out there talking about it. We struggled to get the traction, to get everybody involved. I think everybody thought we were completely mad at the time. It's interesting now. I think there's over 130 public announcements of people now working on hydrogen combustion. And it's interesting. I think there are a good few Chinese car companies now looking at it. So you imagine a hydrogen combustion engine, maybe a hybrid form with an $800 hydrogen combustion engine in a small car. Perfect solution. We're seeing a lot of people now in the truck world start to look at it. Definitely the construction world. So it's probably becoming the most popular new zero CO2 solution for the world. You know, people are really now engaging on hydrogen combustion because they've probably worked with battery and understand some of the limitations. They've worked with fuel cell, and they'll certainly find out what those limitations are fairly quickly. So they end up coming back to, you know, the thing that's great about a hydrogen combustion engine is the supply chain. We know how to do them. We know how to build them. We've got a supply chain. They can be recycled easily. They can be sold in any market around the world. Second-hand value. You know, construction equipment is so important with residual value. You know, many new technologies we don't yet know what the, you know, an electric product may be twice the price of a conventional product. What will the residual value be like in 10 years? We've seen with forklifts in the past, electric forklifts. If you were trying to sell them after 10 years, the next customer would probably want a new set of batteries before they bought the product. You know, ours is a machine, as we talked about. It's not a car. So people would want to make sure that that fuel cell, if you did make it work, then how long would it last, and would I have to replace that fuel cell? Can I really service it? Can I take that apart in the field if I needed to? You know, our machines are very difficult to recover if they've got a major issue with them. But actually we can get in on site, and we can fix it 99% of the time on site. I'm not sure you can do that with other technologies. They all have to be removed, sent back, and brand new components come in.
I want to throw over to Jim Turner in a second, but a question I wanted to ask. I mentioned this when I was talking to our guy from ZQuip earlier this morning about this notion that people are starting to see hydrogen as the great savior and everything else. Bearing in mind that JCB does have a foot in both camps, are you seeing people being a little more reluctant on electric because hydrogen is coming down the pipe, or are people still buying electric machines regardless?
I think we're lucky. We're out. You know, we're one of the first out with electric. We're making traction. It's very hard making traction. So we now have 9 different product groups covered with 21 different individual products. We've sold over 20,000 electric machines. North America is our top market, followed by France with Grand Paris, a lot of underground work, tunneling work, and then the UK, and then Germany. But interestingly, a lot of those products that we sell are things like electric scissors. So the electric world is we definitely are seeing what we call the indoor job site. So more and more electric products are being bought to work underground, to work in basement digs, to allow hotels to go below ground, car park renovations, shopping mall renovations, almost working side by side with some of the battery access equipment. But of course, they are twice the price, these electric products. So if you are renting them, you've got to charge twice as much on the rental rate to make them work. So it has to be a special application where it's maybe not as cost sensitive. You will never ever get a payback on those small electric machines by offsetting the fuel cost because they use so little fuel. So it is very much a hard sell. I think people buy them for very specific applications. We aren't, I don't think, yet seen a natural replacement of the product. Maybe in certain sectors like ag, we've got perfect solutions where you may be working with cows for a couple of hours in the morning and the afternoon. Equestrian centres where they're quiet, they don't scare the animals. They can be worked for 2 hours, then put on charge, and then work later in the day for a couple of hours. So there are perfect applications, but it's a very, very tough sell.
I'm glad you mentioned rental, because to my mind, this ties in with the point that Jim has made here. Once hydrogen becomes the norm, the price will come down. And if it's brought in alongside petrol and diesel, it will have to be similar in price to encourage its usage. One of the things that kind of buzzes around in the back of my head is the fact that the UK market in particular is very, very rental driven. I don't know what the current figures are, but somewhere between 80 and 85% of all equipment is sold into rental. For one thing, rental companies are very conservative anyway. They kind of wait for a pull from the market before they jump in. And if we are to make that switch in such big numbers to get the price of hydrogen down, we kind of need the Lynches and the Flannerys of this world to take a bit of a leap of faith, don't we?
Yeah, definitely. And I think, you know, to be fair, you know, a lot of these companies are very, very passionate about solutions now. So we've had many visits of a lot of our key core customers to site. We show them electric, and they say, okay, but there's still this thing about if I haven't got access to electricity, I have to buy an electric machine that's twice the price of the diesel generator is charging, which seems a bit crazy. And then you end up with, okay, here's a fuel cell. We've got fuel cell excavators. They're superb machines, technically brilliant, but they're just so complicated. So all high volts, very, very challenging technology. You know, fuel cells are efficient, but they're not efficient at low temperatures or very high temperatures. Nobody told us that. The coolant has to be deionized. So we put £2,000 worth of coolant into that machine. What happens if you drop coolant, you know, on a machine that's maybe gone to the Middle East or Northern Africa for a second life, and somebody pours water in, it fries the fuel cell because it's not deionized, so it can short circuit. Lots of things that nobody told us about fuel cells when we started. You know, we thought they were the answer with hydrogen. So that caused us to say, we like hydrogen, let's look at hydrogen combustion. Chairman challenged us to get on and make a hydrogen engine, and that's exactly what we've done. It emulates a fuel cell. We put zero CO2 in and clean steam coming out. So it's a tremendous solution, but the great thing, it works. Going back to the cost of diesel, we've just got to think, in the future, we probably won't have diesel or petrol. So therefore, you only really have three or four choices. One choice is that you add very expensive batteries to your product, and then you pay for electricity. Today, electricity prices are almost parity to a diesel price. So basically, the electricity is more or less the cost of today of diesel, but then you've got to pay maybe another machine cost to run that product. If it's a large machine and you want to work 20 hours a day or 16 hours a day, then you may add 2 or 3 times the cost in batteries to that product. You then take a second technology, a fuel cell. A fuel cell is very expensive because it's just a battery machine, but actually it uses a fuel cell to be the range extender. So that is very expensive as a technology. And then you're using hydrogen. So hydrogen at the moment is expensive, but if it gets down to that 5 or 6, then okay, you've got a good fuel price. You then move across to a hydrogen combustion engine. Of course, hydrogen combustion engine isn't any real expense more than an engine that is today. So the cost of the technology on the machine is pretty much the same as today. So therefore, the only on cost is that slight extra cost for hydrogen in the short term till we get the volume. So you must think about those 3 technologies. You know, they can be very, very expensive to make a fuel cell product or a battery product, and therefore that total cost of ownership. So if you imagine those big machines, maybe 3 times the cost because you're using batteries or a fuel cell, what happens then to your residual value in 5 or 10 years, 15 years time? You know, you need that to be 50% of the product so you can sell it on to make a business model. So in a rental world, that's really, really important. That residual is crucial. And if that drops or that margin is lost, you don't get as much in the residual, and it becomes a real challenge to the business model.
I'll come back. Well, let me just mention this. When we were speaking to the guy from Z-Equip this morning, who do battery modules, I won't bore you with the details, but they do battery modules. And he was saying that they're already seeing a decline in diesel residual values in Scandinavia, because the Scandinavians don't want dirty diesels now. There is a large scale switch to, well, in their case, electric, I think. Is it too early to say that you're seeing that as well?
Yeah, I don't think we're seeing any evidence of that. I think the good thing about construction equipment, and we must never forget it, we all call it currency. The good thing about a piece of construction equipment is you can ship that anywhere in the world. You know, even today, the different legislations, people are doing dual certs on machines, and therefore, you know, if you've got a problem, you need to move a piece of kit, you can move it pretty much anywhere in the world. And I think you're going to be able to do that with diesel for quite some time yet.
I don't know. I don't suppose for one moment he's watching, but I'm going to read this out anyway. I think we're seeing the future, and it isn't electric, says Crystal. Full marks to Lord Bamford, which we'll come back to in a second, for putting his money where his mouth is and backing hydrogen. Obviously, he has done that very, very publicly, and I realise there's a wider Bamford family interest in all things hydrogen. He's celebrating 60 years in the business, which is just astonishing. One of the things that struck me about this is this. We've already mentioned this switch from taking machine or fuel to machine to fuel and all that kind of thing. But this extends JCB's remit to a degree, doesn't it? You're not just providing the machine, and I realise you make engines as well, but you know the very fact that you've got a hydrogen delivery system for delivering hydrogen in a mobile Bowser. That's all additional potential sales, but it's all additional things that you need to concern yourself with now, isn't it?
Yeah, well, we only really got into the Bowser, hydrogen Bowser, because when we were showing our test customers, we showed them electric, we showed them fuel cell, we showed them hydrogen combustion. When we showed them hydrogen combustion, they said, "We get it, we absolutely get it. When can we have it?" But what I want to really understand is, where do I get the hydrogen from, and how do I get the hydrogen to the machine? So we didn't have a refill unit at that time. So we got on and built our own hydrogen Bowser. So really, it is just a number of hydrogen tanks within a small container, and we used a fast track tractor. We extended the rear chassis, so it was a great off-road truck to carry it round. That unit is demountable. So if you're in the rental world, that could be on the back of a 7.5 or a 10-ton truck. And you drive around between the sites and do the classic milk run, as we call it, where you don't have fuel on site, you go to the machine and you drop the fuel in every day. So for us, it was about sharing the dream, if you like. What could we do and how should we do it? In our industry, and especially the agricultural side, is incredibly entrepreneurial. If you can share how it could work, all of a sudden people get behind it. They think, yeah, you do this. And the great thing is, since we've shown them, and since Lord Bamford's talked on many programs about the opportunity, we get great letters every day from people saying, "Have you thought about this? What about this? This would be a great idea. This would work on my farm, or this would work on my site." And I think we're actually creating some real excitement and some real innovative spirit within the industry to say, "Look, I think we can do this. I think we can do it."
Given the fact that the industry is going to have to a degree, come together over NRMM, going to throw over to Gary Muirhead, who says, will there be a universal hydrogen fuel filling adapter fitted to new equipment? Will only a JCB fuel Bowser fill a JCB hydrogen machine? This is actually our opportunity. We mentioned this with electric this morning. You know, this is our VHS versus Betamax moment. We have an opportunity to reconfigure the industry so that there is just one charging solution, one hydrogen solution, fits all sizes. Are we getting there, or are we still all going off in different directions?
No, I mean on a practical level, we bought those components. So hydrogen tanks have been around for some time. There is legislation with them. They have to obviously be tested as a pressure vessel. The rules are much more stringent than we've ever worked with classic diesel tanks. But of course, the fittings, the valves, they're all available in production, and the standards are defined. So I think it's fair to say we can use the nozzle that we use is the same as what would go onto a Toyota Mirai fuel cell car. It's pretty standard. It's an industry standard, and also the valve that it fits to is. So we would love to think we could completely come up with a design that would be unique to JCB, but actually those fittings already existed here as a standard, which is great. I think in some cases there are two types. A bit like your petrol and diesel, you've got one for 350 bar pressure and one for 700, which is good, so you can't mix. But actually, the availability is already standardized.
I think somebody's on the scrounge here a little bit. Dan Cullen says, how can a guy get a test drive on a hydrogen machine to see and feel the difference compared to a diesel engine? Well, I think you sent a very nice letter to Tim Burnhope. I think is probably the starting point.
You'll see them before too long, but just to reassure you, whoever it is, the challenge that Lord Bamford gave us as engineers was that the machine must have the identical feel to the existing machine. So I know we've got our hydrogen machines, we've got a few behind us here in green and white, but if we painted all of our machines, whether it be hydrogen or diesel, all in the same yellow colour and gave them to operators, they wouldn't know the difference, apart from the steam coming out of the exhaust pipe and when you come to refuel it. So the challenge to our team, and we've achieved it, is to have the same torque, the same or slightly better efficiency, the same performance curve. And it's interesting when I drive the machines, and I'm always trying to find out, I'm going to find something with this hydrogen machine where it's not quite as good as the existing, but so far we're there or we're better in all areas. And interesting, we've got over 25,000 test hours on now, and we've discreetly had our machines on the roads around Staffordshire and Derbyshire. We've got 23,000 kilometres of driving on the roads with hydrogen that we've kind of quietly got on with. So we're making great progress. As Lord Bamford uses a great expression, we're proving every day that hydrogen works, and that's what we're up to. We're lucky, our team runs, I think, 32 hydrogen machines every day, backhoes, load-alls, and one or two other units. They're still a bit secret, but we are probably the world's largest hydrogen combustion engine site, working every day, delivering hydrogen, refueling every day, and working machines 24 hours a day. So we are proving that it does work.
Just so you know, you're not the only one that's got a green and white machine, but I've got one up there as well. Just going to throw that into the conversation. Dan Cullen's come back with another question. What about the weight of an electric machine to a hydrogen machine? Is there much difference? That was what I must admit, when I came away from your hydrogen review, whatever it was, a year or more ago, that was the one question I forgot to ask. Obviously, we all know that electric batteries are hugely heavy. How does that stack up with hydrogen? Is that a consideration, or is it not?
No, so hydrogen, engine for engine, it's pretty much the same mass. We then replace the diesel tanks with hydrogen tanks. We maybe have a marginal increase. The interesting thing is it depends on the product. So if you have, for example, a construction load-all that's on site every day, construction load-alls don't consume much fuel. We've spent the last 10 years reducing our fuel or improving the fuel efficiency, I should say, by 50%. And we did that because we thought if we ever do go to battery or hydrogen, then we want to use the minimum amount. So we can get away with hydrogen tanks that are fairly small on a construction load-all. Maybe if you've got a backhoe and it's working very long hours, maybe you need more tanks. But the great thing about them is we can just do auxiliary tanks like we've done in the past, so not everybody carries the cost. But the mass really is insignificant. On the battery side, we're lucky on our machine. So if you take our this little electric machine, I'm not sure if you can see it, but we have to have the same mass, because that machine has to go on the same trailer behind the same transit van in London. So even though we might put what are our batteries, say 40 kilograms, 4 packs, 160 kilograms of extra mass on, taking a very light engine out, we can reduce counterweight on the back and use battery mass to our advantage. However, if you get to a big 20-ton machine, you don't have the luxury of if you're putting 10 tons of batteries on, you don't have the luxury of removing a 10-ton counterweight on the back. Maybe you can get away with 3 tons out. So the danger is a 20-ton machine, in its worst case, would become a 30-ton machine, or in its best case, probably a 27-ton machine. So we have to realise that mass increases significantly with battery technology.
Got a couple of questions that relate to, I guess, maintenance and care of the machines. First is from Ken Hatcher. Is it right that a hydrogen spark plug is £1,000 like a Formula One car? I'll leave you to mull that one over. But Gary Muirhead has actually said, should we be training our plant fitters now for working on hydrogen combustion engines and electric equipment?
Yes, so we've on the electric side, because we've already launched a host of products, we're doing a lot of training. with our people in the field. Of course, with a battery product, if your batteries have an issue, you take them out and you send them back. That's class. You can't really do anything to a battery itself as a unit. They have to come out and they have to be returned. The beauty of the hydrogen engine, of course, is the characteristics are not the combustion process, because that's the magic formula, that's what's unique, but it uses all the principles of a standard engine. The only difference for us, it feels like a diesel engine, but with 4 spark plugs. And the first ones we got were Formula One, and yet they were very expensive. But I'm pleased to tell you we're now through 5 iterations, and we've got spark plugs that live with hydrogen, because we're now putting the right amount of electricity through them. Maybe when we started, we were putting lightning strikes through when we needed gentle sparks for hydrogen, and we've worked that out. So we're in a great position. So we've got very cost-efficient solutions now, reliable solutions. But just imagine when you come to service a hydrogen combustion engine, we've insisted that we've got exactly the same service intervals. So whether it's 500,000, 1,500 hours, whatever it is for that particular product, the only real difference is you may change the spark plugs. Everything else is the same. And the most exciting thing is when you go to service it, even after 500 hours, because it's carbon free, you pull the dipstick and it's pure, beautiful golden oil as it was when it went in. So the oil sadly still degrades, it still wears, so it needs to be changed, which keeps our dealers happy. But of course, it's zero carbon, so it's incredibly clean. Even put your hand in, I'm not suggesting you do this, but if you were to put your hand inside the exhaust pipe of a hydrogen combustion unit, you wouldn't get any soot on your shirt. You know, you'd maybe get a bit of water vapor from the steam, but again, no carbon. So great. So strip the engine down, and it's as clean as it was the day you put it together. Quite incredible.
There has been a lot of talk about concerns over thermal runaway with electric, specifically I think electric vehicles. But Dan Cullen's just asked about do you need any special fire suppression systems on a hydrogen machine? We're still going through. So we're quite lucky. We've got the health and safety group actually based in Buxton, believe it or not, I think 22 miles from where we are. So they've been working on hydrogen solutions in housing and all sorts for many years. And of course, hydrogen's been widely used in the UK, especially for many, many years in many industries. Even in hospitals, it's used for certain reasons. So there's a lot of history to it. We've also had to go through, we've had pretty much every fire brigade from every major county in the UK come and visit us. Staffordshire is going through the protocol of what you would do if there was hydrogen. But the beauty about hydrogen, which is different, so it's pretty much the lightest molecule. So therefore, if you have any form of leak, and not to suggest we'd have one, but if it did leak, it would just rise at 40 miles per hour. So it just goes up as fast as, because it's so light, it struggles to go out over. So therefore, it goes vertically very quickly and disperses very, very quickly. But I think the main thing is that we now have a safe system of work. The delivery of hydrogen, how you use hydrogen. We put hydrogen into our tanks at 350 bar. We like that pressure because our hydraulics work at 350 bar. So it's a working pressure we're used to. Interestingly, the minute the hydrogen comes out of the tank, we regulate it down to less than 20 bar. So we're running actually low pressure lines into our engine. So absolutely superb to control. The interesting thing is that they're all standard sensors that are available in the industry. So if anything is detected, everything just shuts down. So it's really, really good to work with. I mean, we've been working with it for 3 years now. You can imagine we were extremely nervous when we started, and we still have an obsession to make sure that everything is right. Every fitting, we do analysis on everything. Our independent teams here work with us all the time. But actually, it's proven to us that it's actually a great fuel to use on a daily basis. I'm going to swing back around to NRMM as a whole. Obviously, the call for evidence is going on at the moment. How much longer do people have to actually respond to that?
Not long. So the call for evidence, and I brought one with me just in case anybody hasn't seen it. So that's the document, which is you can see is just a heap of questions. It also comes with a report from a company called ERM. So the government commissioned this company, ERM, and that offers technical solutions. They're clearly not construction people, so they have offered some very strange solutions, which are maybe more to do with trucks. And of course, the government will use that information if we don't go back and say how our industry really works. So you've got till the 26th of March to get it in. We're pretty proud that it comes in 2 parts. So I can't show you the details. This is JCB's draft that we're all proofreading now. And that's part 1 and that's part 2 of the draft. And it shows, a lot of information on products, a lot of detail about what happens, what machines do. And we're really getting into the detail to explain as best we can to just explain how our industry works. It's really important. We're working with some very, very clever people in these departments, and they're really keen to understand. But it's up to us to give the information to allow us to share that, to say what works and what doesn't. And I think we just want to be as technology neutral as possible. A lot of things can happen in 25 years, so we just want to encourage in the use of different fuels. Battery has a place. Hydrogen combustion has an incredible place. Agriculture has maybe more challenges. So again, there's lots, but we've just got to share that evidence first, and then we can get into a real consultation once there's a common understanding.
I had a question on the tip of my tongue, which has just gone completely out of my head. Yes, I know what it was. It was about timing. Have the people behind the whole consultation given any indication on when, obviously you're pushing information in, when this might come out as legislation at some point in the future? So
there is a very set process. So what they do is they do the call for evidence. They then take that, review that, absorb that, and then they start to establish a potential plan for a net zero future for NRMM. What they then do is they come back with that as a suggestion, and that starts to go through a consultation process. Quite often they would systematically go through the questions and say, we agree with industry on that, but we're not sure about this. We maybe need more evidence. But the key really is not relying on a later consultation. It's very, very important that you get your evidence in early. And the danger is we talk about it, but we don't give the factual data. So it's really, really important that we share what are the perfect solutions for each of our products, whether it be in any one of those particular segments. And they may be different for agriculture versus some of the construction machines, versus some of the tunneling machines, versus some of the forestry machines. This is the most complicated call for evidence. And I know the size of our task, I think we're probably about 140 pages of absolute detailed evidence to share everything that we know and everything that we recommend for our industry. But you can imagine if all the other industries have to do that as well, it's going to take some doing to absorb that information and to get the right solutions that we need for our industry.
A couple of very quick ones that I want to throw up. Ken Hatcher says, is the legislation for the UK or the world? I think you may have missed the start of the show. I think it is. Obviously, this part is the UK, but a version thereof will be rolled out across the world, I would imagine. Jim Turner says, Tim, you're an interesting fella, and you know your stuff. I could gladly have the crack about machines and the future of our plant industry with you. He's just up the road from you, actually. Thanks for giving your time and coming on Mark's show. Lots and lots of other bits and pieces. Gary Muirhead with a more serious question. Can you get any contamination from using hydrogen? I'm
not sure on what the contamination, not from the fuel. It's a great fuel to use. Like any, if you don't clean tanks out they're delivered in, you may get contamination in, but they'll have fuel filtration systems in like anything else to make sure it's clean. One of the good things about using a hydrogen combustion engine, it can be forgiving with the quality of hydrogen. I don't know if people realise, but when you use a fuel cell, it has to be 99.999% perfectly pure. So some of the hydrogen that you use for a fuel cell, you have to scrub and clean, which uses a lot more energy and therefore causes the price to increase. So again, using an engine is much more forgiving to get the great solution. So I don't think there's anything. We obviously, there's all the questions asked about hydrogen embrittlement. So we've gone through all of our materials in our engine. We understand how they interact. The only real issues are associated with pipework, where you carry pure hydrogen. Once it gets into the combustion process, you're mixing it with air very quickly, and that tends to reduce all the risk. But we've gone through methodically. We have a plan for every part. We systematically go through. We've used some very clever people like the Royce Institute, you may have heard of, to help us. We're working with some universities around the world to just make sure that there's nothing we've missed. They have intensive libraries where they've tested all types of metals with hydrogen to see what happens. So we're systematically going through every one of our parts to make sure we're happy with that solution.
Somebody over on Instagram has just asked if your models in the background are for sale. I'm not going to dwell on that. Warranty on the hydrogen combustion engine. I think I probably know the answer to this because that's been the theme all the way through. These hydrogen combustion engines perform exactly like a diesel. Warranty-wise, I'm going to guess they're probably exactly the same, or will be exactly the same.
Yeah, we want to work in a position where it's the whole solution for hydrogen in an engine should be no different to today's engines. That's our absolute aim, to make sure that to a customer, an engine's an engine, performs the same way, reliability is the same way, just as durable, and is great where you can sell it anywhere in the world when you want to move it on.
Question on hydrogen storage. Can you just store it indefinitely, or does it degrade in any way? Or
yeah, I mean, the like any fuel, I guess it will degrade over time. Most of our fuel on our machines is consumed within a few days, and it will be no different for hydrogen. You may have read that cryogenic hydrogen is where you cool it down to turn it into a liquid. Some companies in the 90s struggled where it started to heat up, so you heated it up and then it turned back to a gas, and they were what you call boil off. But it's interesting now that there are a few people in the world, you've probably seen Daimler with their truck. I think it's done over 1,000 kilometers using hydrogen, but they're using liquid hydrogen on board, which is a really interesting breakthrough. And that would almost, rather than use gas tanks, you would use a liquid form, and the tank would be much more like your diesel tank size, maybe 1.5 times the size. So there's lots going on to perfect how you transport and how you use hydrogen going forward.
I have one final question that this is from me, and then I've got another one from Gary, and then I want to let you go about your evening, Tim. Having watched the progress through stage 3, stage 4, stage 5, and all the A's and the B's in between, I did get the impression for quite some time, and I don't mean specifically JCB. I think the industry as a whole, it almost had to put its R&D on the back burner because it was so focused on getting across those various legislative, regulatory deadlines. Are we going to see that again in the years ahead, or do you think we're beyond that now?
Well, I think it depends on the technology that's chosen. So the car world is going through radical change. So to put the number of batteries you need between the wheels, every car platform has to be different, therefore cars will be updated. However, when you see an electric product, it's interesting that they haven't moved on. So I'm quite surprised that Tesla haven't brought out new generations of cars that have maybe changed the shape and have moved on. So that's a question, because there's big investment. I think we've got to learn how to do both. That's the challenge. I mean, we're lucky where we're a business. You all know Lord Bamford very well. When you've got an inspired leader that wants to drive the business forward, he encourages us. He's encouraged us to do electric. He encouraged us to do new products. He encouraged us to do electric products, to do a fuel cell product, to do hydrogen combustion. Really wanted us to get hydrogen combustion to work because he feels really comfortable with the supply chain. As you said earlier, Lord Bamford celebrated 60 years in the business last week, and we all went down and presented a cake to Lord Bamford, and he said, "That's great." He said, "But we mustn't dwell on the past. We've got to be thinking about the future. Let's keep focused on what's next." So it's absolutely superb to have a chairman of a business and a chief executive of a business that really drive us every day to go and find the great solutions. So We've just got to find a way to keep, often in a downturn, a lot of companies turn down their spend on R&D. We're the opposite. We're encouraged to spend more because the feeling from the chairman often is that when you come out of a recession, people want to buy the latest technology, not an old-fashioned machine. So therefore, they want to be excited about what's new. So it's really important that, you know, we're really passionate to get the right solutions for our industry. We'd hate to think that this call for evidence, that we didn't share enough information as an industry, and as a consequence, machines were developed that our customers weren't happy with. Customers I work with are very blunt. They tell me exactly what works and what doesn't work. They're very straightforward, and I thank them for it. They've always said to me, I mean, I've been working on machines for many, many years, designing machines, and they say you can do whatever you want, but don't make it too complicated or too expensive for this industry. And that's what we got to do. It's a work tool at the end of the day. It's got to pay its way. It's got to either move those bricks or move that earth, and it's got to work. It's got to be reliable. And it's got to have a great resale value so we can sell it on, so we can buy another new machine to keep the business going. Really, really important.
I'm glad you mentioned the chairman, because I've got one final question after this one from Gary Muirhead. Gary says, will you still need to use AdBlue with hydrogen?
We're not absolutely certain as yet. Preferably not. However, we've got incredible clean steam coming out of our engines. We don't know whether we need after treatment or not. So if we did need to have some form of after treatment, you could probably use today's after treatment. But I think by the time we get to the regulations in 2035 or 2040, I'd like to think we were using no after treatment, preferably, or an after treatment that would actually be far, far simpler because of the cleanliness of what comes through that combustion process with hydrogen. I mean, the results for tailpipe emissions are spectacular. We're just going through certification by independent bodies externally, so I can't give you any figures, but I'll tell you they are incredible. So just think about machines, zero CO2, hydrogen fuel going in, and nothing but clean steam, absolutely zero impact to any form of emission issue coming out. I mean, it's just the most remarkable solution. Can be built down the same production line. We can build standard engines and hydrogen engines, so it makes it easy to transition. We've already built over 100 engines on our engine line, proving that we can use the existing process. And of course, we could do the same with machines down the production line, being able to put the engine in that fits in exactly the same space with the exact same characteristics, and be able to work on and service in just the same way. So we're incredibly proud of what we've achieved so far, but we just want to make sure that we get it right, and we want to work with customers that have access to hydrogen to try and prove the machines out to make it a real success.
I'm conscious of the fact that I've already taken up all of your evening, so I'm going to throw this one last one at you, which I guess is almost impossible to answer, but I do think it's worth sharing. Gary Muirhead says, I wonder what Lord Bamford's father would think about all this stuff, hydrogen and electric. Obviously, we can't ask him, but, you know, as an engineer himself, I can't help thinking he'd be really quite excited by it.
I think he'd be incredibly excited, and I think he'd be very, very proud of Lord Bamford. You know, having the same passion and drive that Mr. Bamford did when he started the business all those years ago. Being a family business and having that passion and that drive to get things right for the customer, makes it a real joy to work in an atmosphere where you've got that. It's pretty tough because we want to improve every day and make things better. But it's great. We have a culture of a can-do attitude and a sense of urgency. So when the chairman told us to do a hydrogen combustion engine, it was, we're going to do it, and actually we're going to do it quickly. Let's start proving it. Let's get on with it. We shouldn't be waiting. We should show the world what's possible, and that's what makes it really exciting for all of us engineers.
I'm going to send you away with some happy thoughts from the audience. Where have we got? Gary Muirhead says, fantastic, interesting show today. Thank you, Tim Burnhope and Mark Anthony. Ken Hatcher says, well done, Mark and JCB. What a good evening. Dan Cullen says, amazing information. Thank you, guys. I'd love get together with Tim and Georgina when I visit JCB this year. Fingers crossed. There you are. Tim, it's been an absolute pleasure, as it always is. In my head, I thought this show was going to last for about 20 minutes. Well, I'm only at about an hour out, so
I would have been quite happy with another couple of hours. But
there is a lot of. One of the things that struck me when you were saying about this is the most important piece of legislation the industry will ever face. This is not just a switch of fuel. This is a complete paradigm shift for the entire industry. And I do really appreciate getting somebody of your stature on to be able to explain the whys and the wherefores. Chris Ford said, "Get that man a beer." You get him a beer. You're nearer to him than I am. But I don't think the industry as yet has really had a chance to sit down and really discuss this stuff. And I don't, as I say, really appreciate you giving up your time to actually do that.
Always a pleasure. Anytime.
Fantastic.
Good to talk to you.